Hello, I'm Isaac. I'm a tutor at CWI, and today I'm going to be working through practice exam number 2 for Physics 212. I'm currently on problem number 7, which is probably, out of all the problems that I've done so far, the hardest. And it's not the hardest because it's conceptually difficult, it's the hardest because the algebra is a pain in the ass. But let's go ahead and get started. So, problem 7 states that when a 20-volt EMF, or voltage, electromotive force, is placed across two resistors in series, a current of 2 amps is present in each of the resistors. Okay, so we have some circuit with two resistors in series from some point A to point B. We'll call this one R1 and this one R2. And it states here that when the voltage is 20 volts, that the current is 2 amps. And so we can use Ohm's law now. V equals I times R total. So the total resistance of the circuit. Voltage is 20. Current is 2. So if we solve for RT, it's going to be 10 ohms. Alright, so there's the first part. And we also know that RT is equal to R1 plus R2. And so we can then prove that R1 plus R2 equals 10 ohms. Part 2 says when the same EMF is placed across the same two resistors in parallel, the current through the EMF is 10 amps. So let's go ahead and draw this one. Now they're both in parallel. From A to B, I'll call this one R1 and this one R2. And now the voltage is the same. It's 20 volts. But now the amperage has had a sharp uptake to about 10 amps. Once again, we can use Ohm's law. V equals I times R total. Voltage is 20, current is 10. So if we want to solve for R total, we'll find that R total equals R total equals 2. 20 divided by 10 is 2. That's in ohms. And we know that when we add resistors in parallel, we add them like this. 1 over R1 plus 1 over R2 equals 1 over R total. And we know what R total is. It's 2 ohms. And so we can write this as 1 over R1 plus 1 over R2 equals 1 over 2. Alright, so here's where any mistake in the algebra could make this problem exceedingly difficult. I've found that the best way to go about it is to rationalize these denominators. So in other words, I'm going to times this side by R2 over R2, which is the same thing as multiplying by 1, so I haven't changed anything. And then multiply this side by R1s on top and bottom. So I haven't changed anything because R2 over R2 is just 1, and R1 over R1 is just 1. But now we have a common denominator, so we can add those together and find that R2 plus R1 over R2 times R1 equals 1 over 2. Alright, so now what I'm going to do is I'm going to multiply R2 and R1 on both sides. R2 and R1 on both sides, so it cancels there. And so now we have this expression, R2 plus R1 equals 1/2 R2 times R1. And at this point, I'm going to solve for one of these. So if R1 plus R2 equals 10, then I could say R2 equals 10 minus R1. And now I'm going to need to make some room. So you can see how we got to these two equations. Now I'm going to go ahead and erase everything else to make some room. Alright, So let's go ahead and plug in R2 equals 10 minus R1 for R2 down here. So now we have where R2 was, we have 10 minus R1 for here, then plus R1 equals 1/2. And with R2, we're going to replace that with 10 minus R1. And then multiplied by R1 again. So we've now substituted this into there. You'll notice that there's nothing to FOIL inside of these parentheses. So we can just get rid of those. And R1 cancels with negative R1. So now we have 10 equals 1/2 10 minus R1 times R1. I'm going to multiply both sides by 2. Cancel those there. And get 20 is equal to 10 minus R1 times R1. I'm now going to go ahead and FOIL in R1. So I'm going to get 10 R1 minus R1 squared is equal to 20. And now what I'm going to do is I'm going to put all my expressions on the same size and set it equal to 0. That way I'll have a quadratic formula. So now I have R1 squared. R1 squared minus 10R1 plus 20 equals 0. So the next step is we're going to use a quadratic formula. And to do that, we're going to say that negative b, so if b is negative 10, then negative b is 10, plus or minus the square root of negative 10 squared, b squared, minus 4, a is 1, c is 20, all over 2 times a, which is 1. And this is going to equal to r. Now you'll notice that I got rid of the r1 here, and that's because this quadratic is going to give us 2 answers, and those 2 answers are actually going to be the values of r1 and r2 respectively. But because the problem asks what is the magnitude of the greater of the 2 resistances, we're just going to solve for both of them and figure out which one's bigger. So we end up with 100 minus 4 times 20, which is 80, under the root plus or minus 10 all over 2 equals r. So 100 minus 80 is 20. The square root of 20 is 4.47 roughly. So 10 plus or minus 4.47 divided by 2 is roughly what the resistances are. So the first one we'll take 10 and add 4.47 and divide by 2. So one of our resistors values is going to be 7.235 roughly. And the other resistor's value is going to be approximately 10 minus 4.47 divided by 2, which is 2.765 ohms. So it's pretty clear looking at these that resistor, this is going to be the value of the largest resistance. It's the 7.235. Now if we want to check our answers, remember resistance total in the first series circuit was R1 plus R2, and that was equal to 10. That's what we solved with Ohm's law. And so as you can see, when I add these two together, I end up getting exactly 10. So that's going to prove that we solved this correctly. It's a lot of algebra. It could be a lot worse if you try a different way of solving it. Just remember to never get too hung up in the way you're solving it. If the way you're solving it becomes really difficult and convoluted, it might be good to go back to a certain point and restart the algebra using a different technique. Because sometimes we'll back ourselves up against a wall in algebra, and it's always good to be able to move backwards and start at the beginning again. So hopefully this video was helpful, and I'll see you next time.